National Electrical Code Article 600.43 addresses the requirements for switches or similar devices controlling a transformer in a sign. It is imperative that these switches possess a rating based on at least 125% of the ampere rating of the transformer they control. This requirement ensures a sufficient safety margin, preventing overheating and potential failure of the switch due to the inductive load characteristics of the transformer. Understanding the rationale behind this percentage is crucial. Transformers, especially those used in sign applications, often experience inrush currents upon energization. These inrush currents can be significantly higher than the transformer's steady-state operating current. By requiring the switch to be rated at 125% of the transformer's ampere rating, the code accounts for these transient overcurrents, minimizing the risk of nuisance tripping or damage to the switch contacts. To properly determine the required switch ampere rating, the transformer's nameplate must be consulted. The nameplate provides essential information, including the transformer's volt-ampere or kVA rating, primary and secondary voltages, and corresponding ampere ratings. The ampere rating of the transformer can be calculated using the following formulas. For a single-phase transformer, the formula is ampere equals volt-ampere divided by volts. For a three-phase transformer, the formula is ampere equals volt-ampere divided by volts times the square root of 3, which is approximately 1.732. Once the transformer's ampere rating is determined, multiply that value by 1.25 to obtain the minimum required ampere rating for the switch. For example, consider a single-phase transformer with a volt-ampere rating of 1000 volt-amperes and a primary voltage of 120 volts. The transformer's ampere rating would be 1000 volt-amperes divided by 120 volts, which equals 8.33 amps. To determine the minimum required switch ampere rating, multiply 8.33 amps by 1.25, which equals 10.42 amps. In this case, a switch with a rating of at least 10.42 amps would be required. Since switches are typically available in standard ampere ratings, select the next highest standard rating that meets or exceeds the calculated minimum. In this example, a 15 amp switch would be appropriate. It's crucial to remember that the 125% requirement applies specifically to the ampere rating of the switch. Other factors, such as the voltage rating and horsepower rating, must also be considered to ensure the switch is suitable for the application. The voltage rating of the switch must be equal to or greater than the voltage of the circuit it is controlling. The horsepower rating, if applicable, must be sufficient to handle the motor load, if any, connected to the transformer. Furthermore, the switch must be properly listed and labeled by a recognized testing laboratory, such as underwriters' laboratories, to ensure it meets applicable safety standards. The installation of the switch must also comply with all relevant electrical codes and standards, including proper wiring methods, grounding requirements, and overcurrent protection. It is essential to consult with a qualified electrician to ensure that the switch is properly selected, installed, and maintained. Failure to comply with the National Electrical Code requirements for transformer switch sizing can result in hazardous conditions, including overheating, electrical shock, and fire. Proper switch selection and installation are crucial for ensuring the safety and reliability of the electrical system. The National Electrical Code provides comprehensive guidelines for electrical installations, and it is imperative that all electrical work be performed in accordance with these guidelines. When selecting a switch for controlling a transformer in a sign, it is also important to consider the environmental conditions in which the switch will be operating. If the switch will be exposed to moisture, dust, or other contaminants, a suitable enclosure must be provided to protect the switch from these elements. The enclosure must be rated for the specific environmental conditions, such as NEMA 3R for outdoor use or NEMA 4X for corrosive environments. In addition to the ampere rating, voltage rating, and environmental protection, the switch must also be suitable for the type of load it will be controlling. Transformers are inductive loads, which can generate high voltage transients when the switch is opened or closed. These transients can damage the switch contacts or other components in the circuit. To mitigate the effects of these transients, it may be necessary to use a switch with a specific inductive load rating or to install surge suppression devices. Surge suppression devices, such as metal oxide varistors or transient voltage suppressors, can help to absorb these transients and protect the switch and other components from damage. The National Electrical Code also requires that all electrical equipment be properly grounded. Grounding provides a low impedance path for fault currents to flow back to the source, which helps to protect people from electrical shock and prevent damage to equipment. The grounding conductor must be sized in accordance with the National Electrical Code and must be properly connected to the switch enclosure and to the grounding electrode system. Regular inspection and maintenance of the switch and associated wiring are also essential for ensuring continued safe and reliable operation. The switch contacts should be inspected periodically for signs of wear or damage, and the wiring connection should be checked for tightness and corrosion. Any damaged or worn component should be replaced immediately. The switch enclosure should also be kept clean and free of debris. In summary, selecting a switch for controlling a transformer in a sign requires careful consideration of several factors, including the transformer's ampere rating, the switch's ampere rating, voltage rating, horsepower rating, environmental conditions, load type, grounding requirements, and maintenance procedures. By following the National Electrical Code guidelines and consulting with a qualified electrician, you can ensure that the switch is properly selected, installed, and maintained, and that the electrical system operates safely and reliably. Remember that the 125% factor is a minimum requirement. In some cases, it may be necessary to select a switch with an even higher ampere rating to account for specific application requirements or to provide an additional safety margin. For example, if the transformer is subjected to frequent starts and stops, or if the ambient temperature is high, a switch with a higher ampere rating may be necessary. It is also important to consider the dirting factors that may apply to the switch. Dirting factors are used to reduce the allowable current carrying capacity of a conductor or device based on factors such as ambient temperature, the number of conductors in a raceway, and the type of insulation. If dirting factors apply to the switch ampere rating must be increased accordingly. The National Electrical Code provides detailed information on dirting factors and how to apply them. In addition to the National Electrical Code, other applicable codes and standards may also need to be considered. For example, local building codes may have additional requirements for electrical installations, and industry standards, such as those published by the National Electrical Manufacturers Association, may provide guidance on the selection and application of electrical equipment. It is essential to be familiar with all applicable codes and standards and to comply with them when selecting and installing a switch for controlling a transformer in a sign. Finally, it is important to document the switch selection process. This documentation should include the transformer's nameplate information, the calculated switch ampere rating, the selected switch model number, and any applicable dirting factors. This documentation will be helpful for future maintenance and troubleshooting. Proper switch selection and installation are critical for ensuring the safety and reliability of electrical systems. By following the National Electrical Code guidelines, consulting with a qualified electrician, and documenting the switch selection process, you can help to prevent electrical hazards and ensure that the electrical system operates safely and efficiently. The 125% rule, as outlined in National Electrical Code Article 600.43, is not arbitrary. It's rooted in the understanding of transformer behavior, particularly during startup. When a transformer is first energized, there is a phenomenon known as inrush current. This is a transient current surge that can be significantly higher than the transformer's normal operating current. The magnitude of the inrush current depends on several factors, including the transformer's design, the impedance of the source, and the point in the voltage waveform when the transformer is energized. Inrush currents can last for only a few milliseconds, but they can be several times higher than the transformer's rated current. These high currents can stress the switch contacts and potentially lead to premature failure. By requiring the switch to be rated at 125% of the transformer's ampere rating, the National Electrical Code provides a safety margin to accommodate these inrush currents. This helps to prevent nuisance tripping of the switch and extends its service life. The 125% rule also takes into account the potential for harmonic currents in the electrical system. Harmonic currents are currents that are multiples of the fundamental frequency of the power supply. These currents can be generated by nonlinear loads such as electronic ballast and adjustable speed drives. Harmonic currents can increase the current flowing through the switch and transformer, which can lead to overheating and premature failure. By requiring the switch to be rated at 125% of the transformer's ampere rating, the National Electrical Code provides additional capacity to handle these harmonic currents. It is important to note that the 125% rule is a minimum requirement. In some cases, it may be necessary to select a switch with an even higher ampere rating to account for specific application requirements or to provide an additional safety margin. For example, if the transformer is located in a high-temperature environment, the switch ampere rating may need to be increased to compensate for the effects of temperature on the switch's current carrying capacity. The switch manufacturer's specifications should be consulted for information on temperature dating. Furthermore, the type of switch used can also affect the required ampere rating. For example, some types of switches are more susceptible to damage from inrush currents than others. In these cases, it may be necessary to use a switch with a higher ampere rating or to install surge suppression devices to protect the switch from damage. When selecting a switch for controlling a transformer, it is also important to consider the switch's interrupting rating. The interrupting rating is the maximum fault current that the switch can safely interrupt. The interrupting rating must be high enough to handle the available fault current at the switch location. The available fault current can be calculated using fault current calculation methods or obtained from the local utility. If the available fault current exceeds the switch's interrupting rating, a switch with a higher interrupting rating must be used. It is also important to consider the switch's enclosure. The enclosure provides protection for the switch from environmental factors such as moisture, dust, and corrosion. The enclosure must be rated for the specific environmental conditions in which the switch will be installed. For example, a switch installed outdoors must be housed in a weatherproof enclosure. The National Electrical Manufacturers Association provides ratings for enclosures such as NEMA 3R for rainproof enclosures and NEMA 4X for corrosion-resistant enclosures. In addition to the National Electrical Code requirements, it is also important to follow the switch manufacturer's installation instructions. The installation instructions provide specific information on how to properly install the switch, including wiring methods, torque requirements, and grounding procedures. Following the manufacturer's instructions will help to ensure that the switch is installed correctly and that it will operate safely and reliably. Regular inspection and maintenance of the switch are also important. The switch should be inspected periodically for signs of wear or damage, such as cracked or broken parts, loose connections, and corrosion. Any damaged part should be replaced immediately. The switch should also be cleaned regularly to remove dust and debris. Proper maintenance will help to extend the service life of the switch and prevent electrical hazards. In summary, selecting a switch for controlling a transformer in a sign requires careful consideration of several factors, including the transformer's ampere rating, the switch's ampere rating, the switch's interrupting rating, the switch's enclosure, and the switch manufacturer's installation instructions. By following the National Electrical Code requirements and the manufacturer's instructions, you can ensure that the switch is properly selected, installed, and maintained, and that the electrical system operates safely and reliably. Article 600.43 highlights the importance of this oversizing, ensuring the longevity and safety of both the switch and the transformer.